Thank you all for coming. We're really honored that you chose this talk for your time today. The title of this talk, as you see, is Square Peg, Square Hole, CI/CD that fits.
My name is Madhav Sathe. I'm a platform architect at Pivotal, based in New York.
And my name is Cora Iberkleid. I'm also a platform architect based in New York for Pivotal. And so today, as you're all familiar with the topic, which is great to see, we're going to be talking within the context of CI and CD. And really what we wanted to do was, in light of the fact that as platforms are modernizing and tools are improving, it's easier to achieve powerful CI/CD more efficiently. So we just wanted to touch on a couple of areas and a few tips and techniques that you can use. Specifically, we're going to focus on these three parts of the CI/CD workflow: the testing and the building of the image in the CI portion and the deployment in the CD portion. So if we dive into testing. So when you think about the kind of testing you want to do, the way you want to build your applications, some of the goals that we're striving for in this world of microservices and containerization is to ensure that every application that we're deploying can be released independently of its collaborators on its own release cycle. And of course, importantly, also that it can be rolled back independently. There's also new deployment strategies that are being made possible, and often the more advanced ones require that two versions of the same application are running concurrently. So that's another thing that we need to consider all the way back in the development and CI testing of our application to put us in a position to be able to take advantage of those advanced techniques. So one way to think about it is there are certain gaps in the surface area of your application, right? And those are the points where you integrate with other applications, whether it's APIs or databases. And so for each of those points, you want to make sure that the contract that you have with whatever the other component you're communicating with is being honored across versions. So in particular for APIs, we do want to follow an API-driven strategy, because that's another way to protect the surface area and control that. And if you're doing that, then you want to test those points of contact. So if you can codify that agreement between consumers and producers, then you can use those contracts written as code to actually produce the tests that you use to verify that whether you're a producer or a collaborator, that you're adhering to that contract. And you can also use those codified contracts to auto-generate stubs so that a consumer can be given a stub that is faithful to the contract that has been agreed upon. So the more you do this, the more reliable it is, the more repeatable it is, and the more efficient it is, because rather than having to hand code the tests or hand code the stubs, they're automatically produced. So there are certain tools that will help you get farther in this process. Spring Cloud Contract is a great example that can do all of this. And in particular, the kind of testing that we want to focus on for APIs is if you're deploying a new version of an API producer, then you want to know that if you deploy your application, if your application receives requests from consumers who have not yet updated to that API version, that you can still handle them, right? So that you have made any API changes in a back-compatible way. So if you have your version, and this also means that, number one, that you don't have to coordinate the release with your consumers, but number two, that if the older version of your own application is still running and receiving requests, if you happen to get some of that traffic, you can handle that as well, right? So as a producer, you're being responsible to guarantee your independent release and enable you to take advantage of some of these deployment strategies that require concurrent running. If you're a producer, then what you want to do is make sure that if you're deploying new code, that it'll work with the previous versions of the API that you're consuming, right? And if you can do that, then as a consumer, you can also release independently. And you're also allowing the consumer that you're collaborating with to have the freedom to roll back, right? Because you're not forcing them to upgrade with you. So if you're a newer version, you can still talk to an older version of the producer. So as a consumer, you can actually influence the ability of the producer to have the freedom to roll back independently. So it is important to do this across both parts of the relationship. If you are using Spring Cloud Contract, here's just an example of how you would implement it. So on the left-hand side, you can see a codified contract, so an agreement between a consumer and a producer written as code. In this case, it's Groovy. There are other options. And with Maven plugins from Spring Cloud Contract, that can automatically generate the tests that you see on the upper right. So that would be in the producer code base. These tests would be automatically generated. And so then the producer can use certain mechanisms to generate tests from the current API version or the last API version. And that way, both test that it's meeting the current version of the contract, but also validating that it's back compatible with a former version. These contracts can also auto-generate stubs, as you can see in the Maven repository. That top jar file is actually a stub jar file. It's, again, auto-generated from the code. That jar file is now in the Maven repo, so the consumer can just download it and use that to test against. So even before the producer has finished implementing the changes, the consumer has a reliable stub against which it can test. You want to, of course, then make sure that you're doing this as a practice in CI, right? After you've implemented this as a development practice, you want to make sure your CI pipeline is enforcing this. And it's pretty simple to add these commands into your pipeline. This is sort of the gist of them, both for the producer and the consumer, to make sure that those tests are run. Similar concept in terms of databases. When you make a database change, if you're going to be in that blue-green state, when the when the green application gets deployed and makes a change, you want to make sure not to break the blue application, right? So for that, we want to, again, adopt modern practices like database schema migration tools. Flyway and Liquidbase are two popular ones. And you want to make sure that you're doing not only the tests that you're adhering to that your code works with the changes you made, but that your older code will not be broken by the new changes you made. So that doing that back compatibility check. So here it is. If you deploy green, and green by nature of the deployment through these Flyway or Liquidbase makes those database schema changes, that blue application that you might be running with concurrently, right, to do these advanced techniques or needs to be able to talk to the database. Or if you've deployed the green and made the database changes, and for whatever reason you need to roll back, you can just remove the green application and replace the blue application, and that's a rollback without having to actually do the database schema rollback, which is usually the most complicated part of a rollback. So really great benefits from simply doing this. And what's great is that you can actually do this. There's a few techniques you can employ to do this in CI with an in-memory database. There are more sophisticated ways to do this with spinning up Docker containers dynamically or doing it in a test environment where you have a database. But actually, if you just check out the blue code and redo the test in the blue code, but point to the migration scripts from your green code, you're in essence running the old code with with an in-memory database that represents the new migration change. So really easy trick, build that into your CI. So main point, right? You have to verify back compatibility if you want to be able to release independently, roll back independently, and take advantage of blue-greens and other advanced deployment techniques. So moving on to the build. We have a familiar CI workflow, right? Your developer makes a code change that triggers a CI test the code, build the jar file, build the image, throw that image into an image registry. But actually, this build image stage can be a source of problems, right? There's a myriad of ways to build images, Docker file. Every developer team might be writing that differently, or there's different abstractions that are showing up in the market above Docker file. But if different teams are choosing different ones, then you're going to end up with a lot of snowflakes, which is going to be hard to operationalize around. And that's just sort of the day one generation of the image. If there is something that you need to patch or upgrade in images, or just keep them in a state that is enterprise sort of safe, it's going to be a challenge for the enterprise to be able to do that at scale. We had this problem figured out. If you're familiar with Cloud Foundry, we had Buildpacks, and they kind of gave us all of these wonderful features. The consistency, the predictability, the manageability. They were hosted, so they were easy to host for an entire enterprise and have that consistency across. They gave us polyglot support, so today you're writing Go, tomorrow you're writing Ruby. There's a build pack that handles your app, right? So do we have to reinvent the wheel? Thankfully, no, because now we have cloud-native build packs. So cloud-native build packs basically bring the joy of build packs to Kubernetes. And we have the same polyglot support because we are inheriting the same knowledge that has been honed for so many years now. They give us the same standardization, the same governance, and the same ease. But they're actually an improvement. We've also taken lessons learned from how build packs were built before. And they've been implemented with a bit of an improvement in terms of the modularization of the actual components of the build packs themselves. So we have a base cloud native builder for the base image, and then even within a type of build pack where the Java build pack would have been a monolith before, that's been broken up into individual pieces, so that they're also more pluggable. So I want to highlight some differences. So one is with a Cloud Foundry or Heroku style build packs, the output of the build pack is a droplet. It's by the time it gets instantiated, it will be an OCI image, but the way that it's output from the build pack is a couple steps short of that. Whereas cloud native build packs take that process, shift it a little bit farther to the right, and actually spit out an OCI image. On the left-hand side, they also extend a bit further. So prior to when we had traditional build packs, we were responsible for the Maven build, the Maven package, or the Gradle build, or the equivalent in whatever framework you're dealing with. With cloud native build packs, that can actually be done by the build pack. You can choose to build your jar file separately, but if you haven't, then the build is actually included by the cloud native build pack execution. Another difference is that with cloud native build packs, we have a little bit more control over our image, right? So when you do a CF push, your droplet is kind of locked into the cloud. Whereas with a cloud native build pack, that OCI image is output for you, and then you have a choice of where to store, what Docker registry to store it in, and how to promote it across environments. But the other great thing we had with Buildpacks was the fact that they were hosted. So from an enterprise perspective, it was very easy to make sure that all of your developers had access to the same set of Buildpacks to upgrade them when needed. So wouldn't it be nice for cloud native Buildpacks to also have a hosted version? And in fact, they do. There's an open source project called Kpack, which in a Kubernetes native way gives you a hosted version of cloud native Buildpacks. So in this case, what you do is you configure Kpack to monitor your Git repositories, and when there is a Git push, the Kpack will notice that. It will grab the code, build it, and put an image into the repository that you specified. What's best about that is that it goes beyond what Buildpacks did before and automates the rebuilding of the image, or the rebuilding of a layer of an image, based on an update to the actual build pack. So if there's a base image change, or maybe there's a JDK change, once those build packs are actually updated, the Kpack is also monitoring that, and it will rebase the image as needed. If it needs to pull from code, it will. If it can just rebase a layer of the image without building from code, it will do that. So in your workflow, what does this look like? Now you've got Kpack sitting on your Kubernetes cluster, monitoring your code, monitoring the builders. So you can be at lunch, and if there's a builder change, or if one of your teammates makes a git commit, the Kpack will notice that, build it, and throw it into an image registry. That does mean, however, that any code change would be taken by Kpack and turned into an image, which we might not want to do, right? We might want to be a little bit more selective and make sure that we're only in building unit-tested code, right? So for that, you can use tags or branches to filter what Kpack is grabbing and make sure that you have your CI pipeline ahead of that, tagging the code as you want. But that also kind of indicates that there might be some other features that are missing for enterprises. And so there is actually an option that builds on top of Kpack and gives you some additional functionality. We get that through a tool called Pivotal Build Service. So on top of all of the goodness that we have with Kpack in the cluster, we also have a command line tool called PB that gives us a little bit more deliberate control over when we build our image. And there's a couple of other features included in Pivotal Build Service, some additional builders, some additional integrations in them. It also has a concept of tenancy. So if you're working with a certain development team, you have certain control or certain limitation in terms of the images that you can see versus another team. And it makes it a little bit easier to interact with Kpack. Rather than using kubectl commands to configure it, you have a tool that's a little bit more purpose-built and easier to work with. So in this case, your workflow would look like this, where you would, any code change would trigger your CI. So you do your unit testing, and then you take that more deliberate approach to use the PB command line to have the image built. And you can still have all of that benefit of having Kpack monitor the builder. So if there is a change in the base image or in part of the build packs, then that image is rebuilt for you. This is only a 30-minute talk, so we only have limited time. But there is a demo of this, which is great. So please stop by the Pivotal booth and check that out. And so with that, I'm going to pass it over to Madhav.
Thank you, Cora. Well, what you have seen so far is the excellent way to automate the CI and continuous delivery process. Now we're taking a look at continuous deployment process. What is the desired outcome we are chasing here? The desired outcome of this whole effort is to deliver business agility. Deliver business agility through reliable, safe, repeatable deployment automation. Automate deployment of what? When you're deploying on Kubernetes, you're deploying the automation, you're automating the deployment of Kubernetes resources. such as replica sets, pods, deployments, images that are hooked into those pods and replica sets, config maps, secrets, right? Some of these resources you will iterate on a much faster frequency, such as if you have daily code releases, you will have a daily new container image that you're going to launch. On the other hand, there will be some resources that are not frequently changing, such as services or ingress, right? Depending on the isolation level, you may choose to have a separate namespace or not, or maybe separate cluster or not. At the end of the day, after the automation is done, what you really need is a continuous mechanism to measure what is going into the production. Once you measure it, you have the ability to then analyze it. Analyze what? Analyze the application metrics, analyze the platform metrics, analyze the business metrics. The purpose of analysis is to give you the idea of true health of your production deployment. Once you have an idea of true health of the production deployment, you can decide, you can automate the process of analysis, and during the process of analysis, you can decide whether to go ahead with the new version of the application or roll back, right? That important ingredient makes your automation either stable, reliable, safe or not, right? How much effort you have invested into capturing those metrics. The rollback is also very important, and Cora has covered in great detail how API contracts and API-based development plays important role in that, so I'm not going to go into details of that. The important aspect here is that the human intervention should only be required as part of the business process, never for the lack of adequate automation, right? So that will give you a better business agility. Now let's take a look at what we're going to spend time in next 10 to 12 minutes. We're going to first set up the demo. I'm going to do a git push to my source code and explain what the demo pipeline looks like. We're going to discuss some of the deployment strategies and conclude the demo with the Spinnaker. Okay, that is where the continuous deployment pipeline is configured. Before we get there, let's take a look at the classic Kubernetes abstractions for applications. Your application container code is actually running in the pod, and then you have other resources which are essentially either managing those pods or managing the traffic to pods. On top of that, you have ingress, which essentially deals with look up the service based on the DNS. But other resources, they are discovered using the labels. So labels play a very, very important role in your CI/CD pipelines. So pay attention to those. So let's take a look at what we are deploying here. We have a simple hello service. If you tell a name, it is going to say hello to you, right? It's a V1 of the application is already currently running in the production, and the routing is based on the ingress rules, and the service will map to the parts based on the labels. That's what we have today in production. Now, the developer will come and git push the code. Rest of it entirely automated, completely automated pipelines. When you git push the code to the Git repo, there is a Concourse CI pipeline that will be triggered based on that, and it will do CI testing. It will make sure that the application code is of high quality, and only upon verification that the application code is high quality, only then it will create Docker containers and push that to your chosen Docker container repository. It will then create a new YAML file, which is basically your deployment artifact, that will be pushed to GitOps repo. How many of you have heard GitOps as a methodology? Okay, awesome. So it will push that YAML to the GitOps repo. That will trigger this Spinnaker CD pipeline, continuous deployment pipeline, and that will take that new deployment YAML. And how the Kubernetes does the deployment or upgrade is, it will check whether what is coming in new as a deployment descriptor is different than what is currently running in the system. And only then it will accept the new deployment. And all of this is being continuously monitored by Prometheus. This is the Prometheus has excellent integration with Spinnaker. So it is continuously monitoring what is going into the production deployment. So let us do the git push of V2 of the app code. Hopefully internet will help us. Okay, in this case, I'm just making sure that the new git push happens on this particular Git repo. This is my source code S1P hello application. And what it is going to do is, it is going to update the source code repo here. This is our source code repo for the demo. And yeah, you see that the new Git has been published here. And this is my GitOps repo. So the CI pipeline will pick up the application, new application, push onto the Git repo. The first stage of the process is going to test that application. If the test is successful, it's going to build a container image, right? And Cora has already talked about what is the right way to build container image with security standards ingrained. So you use the right tools, Kpack, PBS, build a container image and publish that container image to the chosen container repository. And once that is done, you're going to go ahead and update your GitOps repo with the new YAML that you want to deploy. The new YAML will contain the new container image reference. And the good practice is to not only use tags, but you actually use the digest, so that you want to make sure that only the right container image goes to the production, right? Because under the tag, a person can actually go ahead and change the image. So you want to make sure that the right image goes to the prod. Now, let us see, the Concourse pipeline is still running, so we're going to check the GitOps repo later. So let's take a look at the Kubernetes out-of-box deployment strategies. What happens when you push the new version of the application to Kubernetes? There are two strategies that are provided by Kubernetes out-of-box. One is the recreate. In the recreate, it basically terminates the V1, which is the currently running application, and then start the V2 of the application. In this case, there is a downtime involved, and obviously there is no simultaneous traffic served by both version V1 and V2. Rolling upgrade is a strategy that is default on Kubernetes. In this case, you have the new versions of the application that are started replacing the old parts few at a time, and eventually all the parts will be replaced. All the old parts will be replaced. This has no downtime, and there will be a time period when both the old version and the new version will simultaneously serve the traffic. So you have to be aware of that. That is where the API-based development comes into the picture. Now, Kubernetes has excellent support, native support for health probe and readiness probe to decide the new pods that are coming up are actually healthy and ready to receive the traffic, right? Now, this is a game changer because it provides a declarative way to rolling upgrade, right? You do not have to write a single line of code to achieve rolling upgrade in Kubernetes. Now, important part to remember here is that there are diverse enterprise requirements that for that purpose you need even more custom deployment strategies. So let us take a look at what Spinnaker provides out of box. Spinnaker provides out of box 3 deployment strategies: dark rollout, Highlander, red black, which is also referred to as blue-green deployment. And in case of blue-green deployment here, it takes a simultaneous traffic, but there are other strategies in which case the switch happens, so there is no simultaneous traffic across blue and green. But what we are going to focus here is our objective of confidence into your CD pipeline. And for that purpose, you need to have automated canary analysis. Automated canary analysis is a tool, is a technique in which you launch the new version application as a canary. You launch the baseline version V1 parts exactly the same scale as canary to make sure that you are performing apples to apples comparison. It's not a good practice if you just compare the new version of the application that has started like a couple of seconds back compared to an application that has been running for a while, right? It's not a good comparison. For a good comparison, you have to have both containers, V1 and V2 containers, started exactly at the same time. You start exactly at the same time with exactly the same scale, and then you have a holistic set of metrics, application metrics, platform metrics, business KPIs, measured into, taken into account, and perform the analysis on that particular stage. What that gives you is a good measure of how successful the new deployment is going to be. If any of these metrics have red flags, your canary analysis phase should fail. That means that will roll back the deployment. If the canary analysis succeeds, all the metrics are showing healthy, only then the new production deployment will take place. Now, here kind of shows what is happening behind the scene when you go to the upgrade the V2 of the application. It depicts what I just described. The V1 is already running, that we already saw. The V1 baseline is launched and V2 canary is launched. V1 is exactly, but it creates a new deployment if you see. There are 2 new parts that are created for V1 and new parts created for V2. Now these are going to be the basis of your canary analysis. Prometheus is going to the tool that we're going to use in the demo to monitor the performance of these containers. And for the purpose of the demo, we have taken into account the container memory. Because it's a Java-based application, so heap leak is one of the causes that you want to take care of, right? If there is a heap leak, you want to roll back, for example. If there is a ACA phase is successful, all the metrics are showing healthy, you will go to V2, go live with V2. Otherwise, you will roll back to V1. So which one is the right strategy for you? We recommend ACA is the right strategy for you, okay, because it has right ingredients into it to have a confidence in your CD pipeline. However, if you have daily windows of daily snapshot releases or daily releases, then you can actually reduce the metrics analysis window. If you have a bigger releases, you can have a larger time window for the deployment. There could be certain scenarios where the ACA may not be applicable, such as Kafka streaming applications, because of the reasons that you can find tomorrow in my other talk. But other concerns are there, which is how do you manage the consistency of visibility of your deployment artifacts? How do you take care of auditing? For that, there is a new pattern emerging called GitOps. In GitOps model, it derives from the DevOps logic. All code must be version controlled. Config is code, so config also must be version controlled. How do you put GitOps and CI/CD together? CI pipeline will create a YAML, CD pipeline will pick up that YAML and put that to the Kubernetes. But with the GitOps approach, Spinnaker has intelligent way of doing this, taking it to the next level. In this case, in the continuous integration delivery pipeline, the Spinnaker will deploy to the staging environment. Upon successful tests of the staging environment, Spinnaker has runtime visibility into staging as well as production environment. So it can create an ACA on its own without requiring the GitOps repos. So it will pull what is running in the staging, that will form your canary. It will pull what is running in your production, that will form your baseline. And based on that, it can do canary without actually depending on GitOps for that particular reason. But you can add a custom steps to do auditing in that case if your company requires that. So let us take a look at what we have here so far. If our CI pipeline is successful and tests have passed, as you can see, the new file has been, this GitOps repo has been updated, and that means it would have triggered our CI/CD pipeline, the continuous deployment pipeline. In the configuration, we configure the Git locations that are necessary for this deployment, deploy the baseline, deploy the canary based on those deployments. Canary analysis stage will compare the metrics. On successful completion of the canary analysis stage, we will go ahead and delete the canary and baseline and deploy to prod. Let's take a running look at what is happening right now. As you can see, the pipeline is already running. And this is a canary analysis stage. In this stage, the baseline has been deployed, canary has been deployed, and is performing the analysis right now. And as you can see, for the amount of duration it has, we have the sampling interval. For that sampling interval, it is going to compare the metrics based on the frequency that we have given. And if the metrics pass, you will actually pass that stage. And out of those samples, how many percentage of the samples actually pass that test? Based on that, you can decide whether your ACA is successful or not. Right? So it is going to take a couple of more minutes to actually go ahead and compare that. If you see here, there is a metrics chart available to see what is going here. You can see that there is a, what is it? Yeah, okay, anyway. So this is basically to prove that if you see here, some application requests are served by canary. So both canary and prod are running, and baseline is also running simultaneously. Upon successful completion of this ACA, if you see here ACA stage, right? That is what is important here. All right. So how much time we have? 2 more minutes? All right. You want me to zoom into this? Yes. All right. So this is the canary pipeline ongoing right now, day 2 pipeline, which is basically your CD pipeline. It is performing the canary analysis right now, but we can also take a look at what has already been done. So this is the successful deployment where it actually, when I did the git push previously, it successfully completed all the ACA stages, and upon doing that, it actually went ahead and deployed the new version to production. And Spinnaker also has infrastructure visibility of what is running. In this case, I have 2 environments, dev environment and prod environment. And for each of the environment, it will tell me how many times I've iterated on that particular deployment. That is how Spinnaker is so intelligently capable of doing ACA without actually depending on GitOps, because it has visibility into runtime environments. It treats service as a load balancer, right? If you see here, service as a load balancer, and it will load balance the workloads across the pods. It will tell you all the services that are deployed. It will tell you the cluster. Each application is treated as a cluster here, and 3 pods. Yeah, all right. Let's see whether our pipeline is going ahead. Okay, the last stage has completed, so hopefully we'll see the successful deployment of the pipeline. In the meantime, we can come back to this screen later, but this is the recapture of what we have done so far. The ACA is implemented in this particular stage. How much time? All right. Cora, you want to cover the key takeaways?
Yeah, so let's try to get back to that demo screen, but, oh, sorry. In the meantime, so the key takeaways are that, as Madhav has shown, there's a lot of more modern and more powerful ways that we can do CD, but they do require that your apps are running side by side. So we want to be able to very quickly take advantage of these and make sure that we're being responsible early on in our development and CI testing practice to be able to take advantage of these things. So back compatibility is key. Also, Buildpacks for Kubernetes on steroids. So what's not great about that? Automated canary analysis. It can really improve the confidence level that you have in your production deployments, and just remember to have good practices and practice good sanitation in your control of your declarative controls. There's some resources that might be useful on these different topics that we've covered. The slides will be published, and then we also wanted to let you know some related talks. A couple of them were earlier today, but the recordings are certainly worthwhile. Andres in particular spends a whole hour on canary analysis, so if that was interesting from what Madhav showed you, really recommend watching that talk. And then we have 2 more talks coming up Wednesday, so please hit those up as well. And that's it. Thanks.
Thank you.